In this video, we'll look at ray diagrams for convex and concave mirrors. Although maybe we'll just do the convex mirrors. So diagrams, convex mirrors. All right, so let's start with that, and let's show the axis here of symmetry, central axis. There it is, and then let's do let's draw a convex mirror. So there, and it. Oh, hi Anya. What are you doing? And so this side of the mirror is has a reflective surface. The rays of light will not penetrate through; they will reflect back. But you may recall, or maybe you don't recall, but if you have a curved mirror that looks like this, then the rays of light that are parallel to the central axis will come in, and they'll reflect back after crossing at the focal point. So you'd have you're going to have a focal point here, where you have your focal point. So let's put an object somewhere out here first. And let's say that we have it outside of the focal point. So here's F, and now let's draw the ray diagrams. Well, you need two rays of light, and you need to figure out where they cross or where their extensions might cross. So here's the first ray. It reflects off of the tip of the arrow, and then it goes in a direction that is parallel to the central axis. Hits the mirror, reflects off the mirror, goes to the focal point. So it goes out like that. And I suspect that, well, anyways, let's give it an arrow. So I think we will have room. Maybe we'll have room. So there. So it goes, hits the mirror, reflects back, and it goes like that. And it'll do. Okay, so they do cross at that location. So first one goes like this, comes back out like that. Second one goes this way and then goes out that way. Where they cross is where you would have the image that forms. And this would be a real image. So this is a real image because it's formed by actual rays of light. If you were to put your eye right in this location here, you would see the image. Likewise, if you were to put your hand here, then the image would form on your hand. You would see the image of the arrow on your hand. Or if you were to place some kind of a screen here, some kind of a reflective surface, maybe some white paper, if you were to place it at this location, what you would see there is the image being reflected off of the white paper, because the actual rays of light would hit the paper here and form the image. And that'll do. Now, in case you're wondering, you could draw many more rays of light here. Not sure if you need to, but 2 rays of light won't give you an image, but if you have millions of them, that'll do. So here's another one. This one will hit the mirror and then reflect off of it, not going through the focal point, but going through that point right there. And here's another one. It's that spot and goes back and gets to this position. And then maybe another one reflects off of the mirror and goes back and hits that spot right there. And all of these rays of light would give you enough of information coming at that specific spot to give you a sense of the image, sense of the object. All right, so the object was here. And there's another type of a drawing you could get out of this. But maybe just to make it clear, if this is your focal point, here's the object. Then you need 2 rays of light. One reflects off of the top of the arrow and then goes through the focal point. And then the second one goes to the focal point, reflects off the mirror, goes back, and wherever they cross is where you would have the image. Let me change that. All right, now let's take the object and put it in the focal, within the focal length. So here's the central axis. Let's draw a curved mirror. Well, I guess that'll do. Yeah, it'll do. And then we have, now I have to make sure that this works out in my favor here. Well, let's put the object put the object. Let's make the object somewhere. Let's put the object somewhere here, and then let's draw it like this. And then the focal point. Let's put a focal point. Let's see. That might do. Here's the focal point. Okay. So I need 2 rays of light that will reflect off of the tip of the arrow and then cross somewhere, or that the extensions of these rays of light would cross. Well, here's one. Out of the billions available, one of them is going to reflect off of the tip of the arrow and go in a direction that is parallel to the central axis, hit the mirror, and then it will reflect back going through the focal point. And so this one goes out like that. Now the second ray of light, you want to draw it in a way that reflects off of the tip of the arrow and in such a way that it goes as if it was coming from the focal point. So like that, right? So draw a ray of light that reflects off of the tip of the arrow as if it was coming from the focal point. So it comes to the mirror. And let's give this thing a direction there. And then as it reflects off of the mirror, it just goes back in the direction that is parallel to the central axis. And it's easy to see that this would have to be the direction, because if you retrace it backwards, if you were to have a ray of light that goes in this direction, and it reflects off of the mirror, then it would have to go through the focal point like that. All right, so now obviously these 2 rays of light don't cross, but if you were to run their extensions, right, here's where your eye is going to be sitting. You're observing it from here. You're looking into the mirror. And as you're looking into the mirror, you see a ray of light that comes to you from this direction. So your brain will think that the information is coming from here. So just run the extension of this thing. And then your brain will think that the information is coming from this direction. And so it will figure out where the information is crossing. This is where it's crossing, and this is where you will think that the object is. This is where you're going to get the image. It will be a magnified image. It will be a bigger image now. The image is going to be bigger than the object. But this is going to be a virtual image. Virtual image, because it is formed by extensions, not by real rays of light, and it's not really there. There's nothing here. This is just an illusion. There's nothing behind the mirror. If you were to go behind the mirror and take a look at that spot there, you wouldn't see the image. So it's an illusion, therefore it's a virtual image. And that does it for the convex mirror. So now let's do the concave mirror. Let's scroll this up. So central axis is what we need. There we need a curved mirror, but now we will make it curved like this. And the reflective surface is on the inside here. Rays of light will come. So here's the object. Let's draw the object. And where will the image form? In the first place, you should recall that if you have a concave, this is a concave mirror. I think this is a concave mirror. Anyways, if you have a mirror that is curved like this, rays of light will come in and reflect away from it. So they will go like this and then go out like that. They'll come in like this and then they'll go out like that. They will not cross. So there's going to be no real focal point. But if you run the extensions, you will have a virtual focal point on this side here, F. So let's say that this specific mirror has a focal point here. This is where the focal point would be, the virtual focal point. And now let's try to figure out how the image would form. So out of the billions of the rays of light available, one of them is going to reflect off the tip of the arrow, hit the mirror, going to go in the direction that is parallel to the central axis, hits the mirror, and then it reflects off of the mirror as if it was coming from that focal point. Like that. So let's draw that. Goes out like this as if it was coming from that focal point. And let's give this direction. This and then out like that. And here's the... Well, let me not draw any extensions yet. Okay, and now I need the second ray of light. So there's another ray of light out of billions available that reflects off of the tip of the arrow here, and it goes as if it was coming towards this focal point. It won't get there, but it's going as if it was going towards that focal point. It's going to hit the mirror here, and it reflect back in a direction that is parallel to the central axis. Let's draw the direction here. So it goes like this and reflects back like this. Now it's easy to see that this is what it would do, because if you retrace it backwards, if you have a horizontal ray of light that comes in this direction, that ray of light is going to reflect out like that as if it was coming from this focal point. All right, now your eye is sitting. Let's move this thing a little lower. It's going to be hard to draw what I need to draw. So let's bring this thing somewhere here. All right. And here's your eye. Draw this thing big. There it is. And you're looking at this mirror. So maybe we'll extend that little ray of light here. All right. So you're looking at this ray of light here. It's coming towards you, and the brain interprets it, the information coming along this path, from all the way from somewhere along this path, so somewhere here. But it also sees the same information coming along this path, and so there's got to be one object there, so it figures out that the object must be here where these things cross. And this is where you're going to have, of course there's nothing there, this is just an image, it's an illusion, and this would be the virtual image. So this is a virtual image. It's just formed by extensions of rays of light. If you were to go behind the mirror, you wouldn't see it there. There's nothing there. The object is here. There's only one way you can draw a diagram for the concave mirror. So this is a concave mirror. But you should check whether this is actually concave, because I tend to mix up concave and convex. Like a 50-50% chance for me to get this thing right. All right, so I think that's it. Well, yeah, that's it for this mirror.